Hello everyone, welcome to the channel. Here we learn computer science concepts in a simple, clear and practical way. And let's get started. And in this video, we'll be discussing about operating system. And to begin with, let's understand what an operating system is. Alright, so when we talk about operating system, we should start with what an operating system is. So there is a question which arises in the people who doesn't know anything about operating system is that whether is an operating system is a physical part of a computer or whether it is a software side. So the answer to the question is that an operating system is basically a program, but it actually manages the computer's hardware. So it actually provides a base for application programs, and it acts as an intermediary between the user of a computer and the computer's hardware. So when we are talking about the operating system, the operating systems are being used by different people, and some may need operating systems for their convenience and others for efficiency, and some need the combination of two. So the operating systems are designed in such a way that it gives convenience, efficiency, and the combinations of two. So before moving on to what an operating system, what are the functions of an operating system, what is really a real time, and to know about what the multi-program and time shared systems of personal computers and other stuff, we need to first understand the basics of operating system by saying what operating system is. So when moving on to operating system, the first concept that we should understand is about what are the four components of a computer. So when we talk about the components of a computer system, there are actually four components, and the first thing is hardware, and the second one is the operating system, and the third one is application program, and the last one, which is the fourth one, is the user. So in here I have been showing you the picture, an abstract view of the components of a computer system, and you can see in depth level you can see the computer hardware, and on top of that you can see the operating system, and above that you can see the systems and application program, and inside it you can see compiler, assembler, text editor, database, etc. And many users are using these application programs, which is listed here. So when we say about hardware, what are the hardware parts of a computer? So I can say that the hardware parts of a computer are the central processing unit, CPU, the memory, and the input-output devices, or also called I/O devices, which actually provides basics of computing resources. And when we talk about the hardware, we should also talk about the application programs. And I can say the examples of application program has the word processor, spreadsheet, compilers, and the web browser we use for browsing every day. So what the operating system do is that it controls and coordinates the use of hardware among these various application programs for multiple users. So we can say the operating system in two viewpoints, like it can be set from user's view, and I can also say it from the system's view. So let's dive into how the operating system looks like from the user's viewpoint. The first big idea about the operating system is that it is made differently depending about who is using the computer and how they use it. So just like a bicycle or a bus and a train are vehicles, but they are designed differently because they serve different people and purposes. Imagine if you're using a single user or a personal computer, and you're sitting alone at a desk with a screen, also a monitor, called as a monitor, a keyboard, a mouse. This computer is yours alone, and you are the only person using the computer. You're typing slowly, you click slowly. Sometimes the computer waits for you to do something. And think of the OS as a very polite helper sitting inside the computer, and it says, I'll manage things easy for you, and I don't mind waiting if you are slow. So the ease of use is most important here and the performance matter. But it's okay if the CPU is idle, memory is unused, and the system is waiting for you. A good example for this is that a Windows on a home PC, a Mac OS on a personal computer. So here the OS cares more about your comfort than squeezing every drop of power from the machine. And so this is the first scenario where the operating system has been used. Then coming to the second scenario where many users on one big computer or the mini computer or mainframe. So imagine a huge computer in a room and many people are sitting on different terminals and all connected to that same computer. For an example, like one big pizza and many people wants a fair slice of it. So everyone is using the same CPU and the same memory and the same disk and printer. So here the OS becomes a strict teacher and it says everyone gets a turn and no one is allowed to be greedy. So the OS shares CPU time fairly and shares memory carefully. And make sure that no user takes more than their share and the computer is always busy and not ideal. So here an example for that is that a university mainframe or an old banking system where the OS is designed for maximum resource utilization, not personal comfort. And this is the second scenario where the user is using an operating system in a different way. And coming to the third scenario where there is a workstation connected by network. So imagine you own your computer on your desk, but it is connected to a file server, a printer server, and other computers on the network. So your computer is yours alone, but some things are shared over the network. So you type and work independently, but you may share files, printers, and computing services. So the operating system here tries to be balanced. Like it says, I'll manage the computer, pleasant for you, but I must also play nicely with others. So the OS here focuses on the usability for you, still cares about the efficient sharing of network resources. So for an example, if we say about the Linux workstation in offices or the Windows machine for corporate networks, here the OS is a compromise between the personal comfort and the shared efficiency. So this is the third scenario about the user is using an operating system. Coming to the fourth scenario, I can say if the operating system is used by a user with a handheld device. So now you think about a smartphone. You know, a smartphone is very small, portable, and it runs on a battery. So what special is happening here? Here the battery life is precious and screen and input are limited and often used by one person only. So here the OS becomes very careful and it says don't waste your energy, don't do unnecessary work. So here the OS tries to save power, limits background tasks, focus on smooth performance, long battery life and simple interactions. So here Android and iOS can be said as an important example and here power efficiency is just as important as performance. So this is the fourth scenario where the operating system is being used by the user in a different way. And the fifth scenario, which I can say is about the operating systems used in embedded system, where there is almost no user. So imagine about a washing machine or a microwave, a car engine controller. So these do not have a screen or do not have a keyboard or doesn't wait for humans to use them. So what is happening here? Here the computer runs automatically. It responds to sensors. It controls heartbeat directly. So here the OS is a silent robot and it says, I'll just do my job, no questions and no interactions. So the OS runs continuously, needs no user interventions, and it focuses on the reliability, predictability, and correct control. So here the user's view almost does not exist in an embedded system. So the final big understanding here is that there is no single best operating system design, and instead the operating system is requires different, so here the different users, different devices and different environments require different operating system goals. So in simple words, which I can say that when we talk about the user view is that a personal computer, when we're using a personal computer, the operating system we need from the operating system has a comfort. So when we talk about a shared big computer, fairness and efficiency is what the operating system looks for. And for the network workstation, a balance should be needed. And in mobile devices, battery and usability is what we need from the operating system. And in the embedded system, automation and reliability is what we needed. All right, so right now we have learned about the operating system from the view of a user. So next we will check the operating system from the system's view. So as we know that an operating system is the boss, a referee, a traffic police of the computer. It sits closest to the hardware and everything else must go through it. So the operating system from the computer's point of view, we can say has it's a closest friend of hardware. So imagine that your computer hardware is very strong, but a very dumb robot. It has arms, like in the case of computer, we can say it's a CPU. It has memory and it has eyes and ears like keyboard, mouse, screen, and disk. But the robot doesn't know what to do by itself. So the operating system is the robot's brain controller. So it talks directly to the CPU, memory, disk, keyboard, screen, and printer, and no other program is allowed it to touch these things directly. The operating system acts as a resource allocator. So imagine you have a toy and you need to share that toy. So everyone wants the toy. If there are many children, everyone wants the toy. So who decides it that which person gets a toy? So here in the case of a computer, the operating system decides who gets a CPU and who must wait and how much memory can each program use and who can use the printer. So this is called resource allocation. So the OS must do this effectively, that things should work and efficiently, that there should be no wastage and it should be fair, like there's no cheating should be there. So if there are two conflicting requests, like if two program might say like I need the CPU now and another person say I need the printer now. So if no OS exists, then there will be chaos or crashes, or there is a chance for a frozen computer. So the OS decides and controls like a traffic light what to do next. So the operating system here acts as a control program, or in other way we can say that an operating system is a strict teacher. So it says, program, you must not touch memory that isn't yours. And at times it say, program, you may not crash the system. And it may also say, program, wait, it's your turn for the disk. So because programs can make mistakes, it can misuse hardware and it can harm other programs. So the OS control program execution to prevent errors, improper use, and damage to the system. It's especially important for input and output devices like disk, keyboard, and printers. So just think that if there is no operating system, so imagine you're buying your CPU, memory, disk, but there is no OS. So you would have to manually control the hardware, write code to talk to the disk, and handle keyboard signals yourself. So it's impossible for the normal user, right? So we created application programs, but they all need common services. So instead of repeating the same code, we put all common control codes into one program, and that program is known as the operating system. So what exactly is an operating system? So the important thing is that there is no single or perfect definition for an operating system, but we can say operating system from a different viewpoint. So there are different viewpoints which exist. So first view is that it's a vendor view. where the operating system is everything that comes in the box. Like it includes kernel, editor, utilities, and system tool. I'll say about what is a kernel, what's an editor, or utility and system tools in the upcoming lectures. So there is another view that say the operating system is more common and simpler. That the operating system is one program that is always running. So everything else like browsers, games, editors, or application programs. And actually, this is a definition that we usually follow. There are storage sizes like computers counts in the power of 2 and not in 10. So like for 1 KB is equal to 1024 bytes, and 1 MB, which is megabyte, is equal to 1024 KB, and 1 GB is equal to 1024 MB. But companies like round numbers because they look bigger. So they say 1 MB is equal to 10 lakh bytes. So this causes confusions, but both are commonly used. So there are different types of operating system. There are tiny, some are huge, and these size depends upon the features, purpose, and the target use. So right now we learned about what an operating system looks like from the system's view. So there are a little bit of things that we should know as an introduction to operating system. So for that, I would say a simple story to say how the operating system changes over time. So I'm taking here Unix as an example. So early Unix had only keyboard, printer, there was no graphics, and it was not very user friendly. Later, hardware improved, screens improved, and mice appeared. So Unix moved into new hardware, added graphical interface, became easier to use, and still cared about efficiency. So operating system evolved with hardware. The operating system is hard. So designing an OS means choosing between speed versus simplicity or power versus usability and making trade-off. Also, many people work on one operating system. It is constantly updated, fixed, and improved. Whether an OS is good depends on who is using it. So the OS and the hardware actually grows together. So this is a deep idea where a new hardware means a new operating system idea. A new operating system problem, then a new hardware feature. So an operating system needs protection and hardware adds protection to it. Operating system needs multitasking and hardware supports it. So operating system and computer architecture involves each other. And why we should learn about the history of operating system. By looking at how operating system developed over time, we see common patterns, repeated problems, and why certain features exist. So history explains why modern operating systems look the way they do. So all right, that's about the introduction to the operating system. So this is the end of the video lecture of today, and we will be continuing the other parts like mainframe systems, and in mainframe system we'll be learning about the batch system, multi-programming system, and time-sharing system in the next parts. Until then, it's bye from Bits by Bits Lumera.